Hi, everyone. Welcome to my channel. This is the Hungry Math Professor here, and today I'm going to be quickly reviewing this book, Lectures on the Philosophy of Mathematics by Joel David Hamkins. And I've recently become like really obsessed with philosophy of mathematics, so I've been reading a lot of different things. But I really like this book in particular. It was published in 2020, and Joel David Hamkins is a great author for something like this. He's the O'Hara Professor of Philosophy and Mathematics at Notre Dame. And I really like reading this guy's papers. I've read several of his papers and watching him speak, and I've heard him on several podcasts. Maybe I'll link to some of those. He's really fun to listen to. And one of the things that makes him really special, so he's a mathematician, he's a set theorist in particular, but has a very sophisticated understanding of philosophy as well. And many mathematicians don't really care for philosophy. So it's really special that Joel is a very prolific mathematician, but also a very well understood. He understands philosophy really well, and so he's a perfect person to write a book like this. And one of the things as I'm reading philosophy of mathematics as a mathematician is sometimes I'm disappointed at how little mathematics actually shows up. It feels like if we're talking about philosophy of mathematics, there should be lots of examples, of actual mathematical objects or mathematical theorems and it feels like a lot of times in literature there's just not enough math in the in the discussion, right? And I start to wonder like how much do these philosophers actually understand the mathematics itself? How much time have they spent wading through the mathematics and building intuition and building insight? I understand that you need to also have a very deep understanding of philosophy, and you can have these sort of metaphysical arguments without a ton of specific mathematics in the discussion. So I understand that. But I'm just admitting that as a mathematician, I wish there was more math involved in the philosophical discussions. And that's why Joel is such a great person for this book. And in this book that I'm talking about, he so successfully weaves in so much mathematics into the philosophy discussion. At times, you feel like you're reading a math book, um, but he always brings back the philosophy. And I think this is the right approach because um, when you're doing philosophy of mathematics, there's not always such a clear distinction between where the philosophy starts and where the mathematics starts. And to me, that's the way it should be in this topic because, sometimes as a mathematician, I wish we did bring in a little bit more philosophy into the discussion, um, but in a way that like was really weaved into the actual mathematics. And you also are going to learn, a lot of history in here. And, Joel covers many different topics, many interesting topics. He starts out with, numbers and ontology, this very philosophical question of like, what exactly are these numbers that we're doing? What are the natural numbers? What are the real numbers? Really, so he covers various different philosophical positions there, but also just teaches you about lots of different number systems and different mathematical properties of them and how and the sort of philosophical implications that has. He goes into rigor, like what does it mean for an argument to be rigorous? How do we decide that? Is it just a social construct amongst the mathematical community, or is there some other sense in which um, we should define rigorous? And he also talks about just the historical development. And the classic example here is calculus and how we needed more rigor there. And he talks about infinity, this sort of thorny, necessary thing in mathematics, geometry, proof theory, computability. He talks about the incompleteness theorems that I've mentioned in other videos. And then he ends talking about set theory, the most accepted foundation for mathematics, and he gets into his multiverse view of set theory, which I find extremely interesting, and it's like a teaser for some of his other papers. So I highly recommend this book if you're interested in learning some philosophy and also learning some mathematics. My only concern is that the mathematics. I mean, I'm a math professor, so I know all this mathematics, so I can read this very nicely through. My only concern is that if you're not super familiar with the mathematics, it might be a little too fastly presented in this book for you to actually get it. So I'd be curious if you check out this book, let me know what you think. Am I right about that, or is it at the right level? Okay, thank you. Like, comment, and subscribe, and I hope to see you at some other video.